So let's look at the continuous frequency distribution. So we've already seen discrete frequency distribution. Now we have to see continuous frequency distribution. So what you have to understand here is you don't have discrete data. What you have is these classes. So your data is somewhere in this range, and the frequency of the data is given, right? So how do you get the mean, median, mode for these three cases? So I've written the formulas, but to interpret these formulas is what I'm making this video for. So I won't be calculating the exact values, but I'll help you interpret what is to be done. So what will be given to you is only these two quantities, class and frequency. From this class and frequency, you need to make this table of class mark, right? So class mark is something that lies in between the intervals. So 10 to 20. What will be there in the middle? 15 will be there. So it's 15 here. So upper limit of the class plus lower limit of the class by 2. 20 plus 10 by 2, which is 30 by 2, which is 15. Here 30 plus 20 by 2, which is 25. 50 by 2 is 25. Likewise, you'll make a table of class mark. Now to get the mean of this data, you simply have to take sigma fi xi by n, right? It's already written here. What is n here? N is the cumulative frequency of all frequencies, the cumulative frequency. So basically 3 plus 10, which is 13 plus 5, 15, which is 28, 28 plus 2, 10 is 28 plus 2, 30 plus 10, 40. So 40 is what you will get from here, right? So this is your n. This is your n, capital N. And sigma fi xi is basically you will take 3 into 5, which is 45. 20 into 15 is 250. And likewise, you'll make the table of sigma fi xi. You'll multiply the frequency with the corresponding class mark. You'll carry out these products. You'll make this table here and you'll carry out the summation. The result that you will get, you'll put here and you will divide that with n. That's how you'll get the mean. Coming to the median. How do you get the median from this data? So once again, median is not difficult. So here this is the formula. L by 2 plus h by f into n by 2 minus c. This is c. Let's interpret every data. What is L? L is the lower limit of the median class. How do I get the median class? So basically this is your cumulative frequency, right? So first what I have to do is I have to make a table of cumulative frequencies to carry out this operation. Remember that. So let me make a table of cumulative frequencies. So cumulative frequencies, you start from 3 plus 10, which is your 13, 13 plus 15, which is 28, 28 plus 10, which is 38. Right, and 38 plus 2, which is 40. So how you will get the median class? That is the question here, right? So n by 2, what is your n? 40, which is your last cumulative, like the total cumulative frequency, right? This is your n, the last or the total cumulative frequency. N by 2, which is 40. 40 by 2 is 20. So you will take that column, or you will take that class whose cumulative frequency is greater than or equal to 20, right, or closest to it. So 20 will lie somewhere 3, 13, 20 will be somewhere here. Greater than 20 is your 28, so I'll choose this 28. So that means this is my median class, right, because 28 lies here. So to get this, I need to make this cumulative frequency table, otherwise I wouldn't know, right? So remember that. So this lower limit of the median class, which is 30, that is your L here, 30, according to this. What is the size of the class? H. Size of the class is 10 because it starts from 30 and goes to 40. So 40 minus 30 is 10, right? Frequency of the median class, that you'll get from here, 15, right? And cumulative frequency of the pre-median class. This is also one more thing. Cumulative frequency of the pre-median class. This is your median class, right? What is the pre-median class? This is the pre-median class, the one which is before this. And what is the cumulative frequency there? It's 13, right? So it's 13. And capital N is cumulative frequency until the end. That's basically your capital N, right? So basically that's 40. You put in the values in this particular formula and you will get the median of the data. Coming to mode, for mode we'll be using this formula. Capital L plus f1 minus f0 by 2 into f1 minus f0 minus f2 into I, right? Now this L differs from this L. This L was the lower limit of your median class. This L is the lower limit of modal class. How do we get the modal class? So modal class is very easy. What is the meaning of mode? First of all, mode was that data which occurs most number of times. That means it has to have the greatest frequency. Which of these have the greatest frequency? 15, right? 15 has the greatest frequency. So this class, which was your median class, is also the modal class here because it has the greatest frequency. Now the lower limit of that, which is 30. That is your L here. So in this case also your L is 30. What is F1? Frequency of the modal class, which is 15, right? 15. Now F0 is the frequency of pre-modal class. Pre-modal class means the one which is before your modal class. That's the frequency there is 10. So this is 10, right? And F2 is the frequency of the post-modal class. This is your modal class. The post-modal class is this, right? So the frequency of this is 10 again, right? And I is the class interval, which is basically the interval or length of the class, which is 10 here in this case, right? So once you plug in these values in this particular formula, you will get the answer for the mode of the data. This is the formula for the mode, this is the formula for the median, and this is the formula for the mean. I would also like to give you this relation, which is extremely important. Mode is equals to 3 median minus 2 mean. So sometimes it gets difficult to calculate mode, median, and sometimes it's easier to calculate mean and median but not mode. Sometimes it's easier to calculate mode and median but not mean, right? Calculations, it's all calculations, as you can see. So you can always use this relation. So if you get the mean of the distribution, if you get the median of the distribution, you can use this formula to get the mode instead of going directly by the mode formula. It's all your wish, right? So this is how we calculate the mean, median, mode of continuous frequency distribution. Let us now look at the measures of dispersion for continuous frequency distribution. So let us now look at this continuous frequency distribution table, and what we are trying to see now is measures of dispersion for this particular form of arrangement. So we've seen three types of data now. One is your ungrouped data, one was your group data but discrete frequency distribution. This is your group data with continuous frequency distribution. We saw mean, median, mode for all the three cases. We are finally ending with the measures of dispersion for this. We've already seen measures of dispersion for ungrouped data, then for frequency distribution, discrete frequency distribution data, and now we are seeing measures of dispersion for continuous frequency distribution data. So this is slightly more different, as you already saw that mean, median, mode for this particular form of data was very different from ungrouped data and discrete frequency data. Likewise, this variance and standard deviation are also slightly different for this. So here what you have to do is mean deviation about the mean and mean deviation about the median is the same. You don't have to do a lot here. So just that you'll be given this column and this column in the question. You need to make this xi column, which was your class mark, right? We already know this. It's the midpoint of the class. So you take the midpoints of the classes and you put them here, right? Then what you do is you assume a quantity called A from this, right? You assume a quantity called A, and that's basically this quantity in the middle. So you take all the classes. The class mark of the middlemost class is what your A is. So this is what you will call your A, right? With the help of this A, you will make this column called Di. You won't need this column for this and this because these are very simple, right? If you have if you have x bar available with you, how do you get x bar? Basically, you take sigma fi xi, right? You have xi column, you have fi column. You take sigma fi xi and divide that with n. What is capital N here? Capital N is the sum of these frequencies, right? You'll put that here. So sigma fi xi will help you get x bar, right? Once you have x bar available with you, you have each of the xi's available with you. You have fi's available with you. You have capital N. You can always get mean deviation about the mean, right? Similarly, mean deviation about the median. You have xi available with you. You can calculate the median of this data. So in the previous module, we saw how to calculate the median of this data using that formula. So you use that formula for the median and get the median of this. You have xi available, so you'll make a column for xi minus n, and then multiply that with the corresponding frequencies and sum them up, and then divide that with capital N. You'll get the mean deviation about the median, right? So for these two, you don't need this Di. You need this Di for variance and standard deviation. What is this Di now? You get Di using this formula. Xi minus A. Xi is each of these values, right? And then you subtract this middlemost value A from each of those. So 14.5 minus 34.5 is minus 20. 24.5 minus 34.5 is minus 10. Likewise 0 and then 10 and then 20. This is your Di. Now you have DI available, so you can always get the DI square column, which is your 400, 100, 0, 100 and 400, right? You have Fi available with you. So Fi into Di square you can always do, right? You can always make a column like that, sum them up, divide that with capital N. You'll subtract Fi Di, so now you'll multiply Fi with Di instead of Di square, make a column of Fi Di, right? And then sum them up, divide that with capital N and square this whole quantity, right? So basically you'll make the required column, you'll put them in the formula, and then you'll get the variance of the data, right? I'm not calculating the variance, that's a work for you. And once you get the variance, then getting standard deviation is not difficult. You just have to take the square root of variance, and that's how you get standard deviation. So this was the formula. I had to explain you the formula. Now you're supposed to do just maybe 1 or 2 questions based on these formulas, based on, in fact, all the formulas that we have seen in this chapter, and get them registered in your head, because there's not a lot of concept involved here. It's only brute force, basically using the formula as far as the questions are concerned, right? So with this, we are almost done with the chapter. Let's look at this last small thing called coefficient of variation. And with that, we'll complete the chapter called statistics.